Good afternoon, all of you. Last class we discussed limit, right? The basics of limit. What is the fundamental principle behind limits? Then we discuss limit laws, right? The rules of the limits, right? So how we can apply the limit for the different types of scenarios, right? After that limit laws, we discuss how we can find out the answers by applying factorization techniques, right? So sometimes, let's say, if you try to get the limit value of an equation directly, you are getting answer 0 divided by 0, right? So we cannot get 0 divided by 0 as an answer. This is undefined in mathematics. So at that type of scenarios, what we can do, we need to apply different techniques, right? So the first technique we will discuss, just we can apply the factorization techniques, right? Factorization techniques, in the sense, if you have an equation, let's say if you look at this example, right? What is the question? Limit x approaches 3, right? So if you directly replace 3 for all the equations, what will happen? 3 to the power 2, 3 to the power 2 minus 3 into 3, 9 over 2 into x to the power 2, 2 into 9 minus 5 into 3, 15 minus 3. So it means 3 to the power 2, 9 minus 9, 0. 0 divided by 2 into 9, 18. 18 minus 18, 0. 0 divided by 0 is the answer. So we cannot provide 0 divided by 0 as an answer for any mathematical formulas, right? So for this type of questions, what we are discussed, if you can't get the answer directly putting the limit value, the first technique we can apply the factorization. So let's say x squared minus 3x over 2x squared minus 5x minus 3. So if you apply factorization for this equation, so in the top element we can take x as a common, then the remaining part x minus 3, right? So the remaining part is x minus 3, right? So here we have a remaining portion x minus 3. So if you apply factorization for the bottom elements, right? So maybe you can apply whatever the factorization techniques. I am using 2x into x, 2x squared, 1 into 3, 3, right? But we need minus 5, right? So 1 into 3, so minus 3x. Here, no, it's not the correct way, right? So here plus 1 minus 3, so minus 3, so minus 6x plus 1x minus 5x. So we can apply the factors 2x plus 1 into x minus 3, right? We can cut down this x minus 3 and x minus 3. Then what will happen? So if you apply the factorization technique, we have x over 2x plus 1, right? So rather than we are take the limit of this one, right, we can directly take the limit x approaches 3, x over 2x plus 1, right? So what they are telling, both are same. So now if you directly apply the limit here, right, limit x approaches 3, limit x approaches 3. So for x we can put 3 over 2 into 3 plus 1. So 3 over 2 into 3, 6 plus 1, 7. So 3 over 7 is the answer for this question, right? So I will show you, right? So if you go through these steps, right, you are getting 3 over 7 as the answer, right? This is the way how we can apply factorization techniques to get the limit value. So when we can apply factorization technique, if we cannot get the limit value directly, right? So if you cannot directly apply the limit techniques and you cannot get the answer, or maybe you are getting answer 0 divided by 0, likewise undefined things, then only you can apply the first step. We can take first technique, we can check whether is it possible to apply factorization technique, right? Some cases, right, if you cannot apply the factorization, then we need to check another different techniques, right? So before moving to the second techniques, right, let's say I will explain this one, right? So here what will happen, limit x approaches minus 3. here also if you directly put x squared plus 4x plus 3 over x squared minus 9. So if I directly put the x belongs to x approaches minus 3 to the power 2 minus 3 to the power 2 minus 3 into minus 3 plus 9 plus 4 into minus 3. So 4 into minus 3 minus 12 plus 3 over x squared means 9 minus 9. So we are getting answer 12 minus 12 0 divided by 0. So we cannot provide directly 0 divided by 0 as a answer. So what is the way we can find out for this type of question? So what we can do, right, let's say rather than we are directly apply limit, first thing we need to apply factorization technique. So here we need to factorize this one, right? So if you factorize x squared plus 4x plus 3, right, we can directly factorize x plus 1 into x plus 3. I am directly writing. If you can't directly find out the factors, you can apply whatever the factorization technique we already discussed and you can find out the factors, right? So I can directly write the factors. X plus 1 into x plus 3 are the factors, right? So x squared plus 3x plus x 4x plus into plus 1 into 3 plus 3. So here x squared minus 9. X squared minus 9 we can write as a x squared into 3 to the power 2. So this is similar to a squared minus b squared. So we can write a minus b into a plus b. So x minus 3 into x plus 3. So both sides we can cut down x plus 3. So now rather than we are calculating the limit for this one, we can directly find out the limit x approaches minus 3 x plus 1 over x minus 3. So now if you directly put the value for x as a minus 3, x approaches minus 3 plus 1 over minus 3 minus 3. So minus 3 plus 1 minus 2 over minus 6. So both sides minus into minus plus. So 2 over 6 it is equal to 1 over 3 is the answer, right? This is the answer what we are getting, right? This is how we can apply factorization techniques and find out the answers, right? I already explained some scenarios we cannot apply factorization techniques to find out the answer, right? That type of situation, the second techniques what we can do, we can apply the, let's say the second type, let's say if in your equation if you have any square root values, right? If you look at this example, limit x approaches minus 1, let's say limit x approaches minus 1, here also we cannot directly find out the answers. So if you directly find out in the sense, here square root of minus 1 plus 2 minus 1 over minus 1 plus 1. So now what will happen? 2 minus 1, 1. Square root of 1 is equal to 1. Square root of 1 is equal to square root of 1 minus 1 over minus 1 plus 1, 0. Here square root of 1 is equal to 1 minus 1 over 0. So 0 divided by 0 is the answer. So this type of scenarios we cannot provide 0 divided by 0. That is undefined. So what we can do, if you have any square root in your equation, right? So let's say that is we can call conjugate square x plus 2 minus 1. So entirely we can say this is a conjugate, right? This is an expression with the square root. So now what we can do, if we have this as a expression, the conjugate of this one x plus 2 square root x plus 2, here if you have a minus 1, the conjugate of this one is plus 1, right? Similarly, if you have a square root of x plus 2 plus 1, the conjugate of this one, this is, right? So now what we can do, this type of questions, what we can do, I already explained, right? If you have an equation, on that equation, both sides, if you take the same operations, nothing will happen, right? Maybe both sides you can take some addition, both sides you can take the same subtraction, or both sides you can take the multiplication, or both sides you can take the division. Your equation will not change, right? So now what will happen? Let's say x is equal to x approaches minus 1, right? This is the equation, x plus 2 minus 1. So this is the expression over x plus 1, right? So the conjugate of this one, x plus 2, square root of x plus 2 plus 1, both side I can take the multiplication, square root of x plus 2 plus 1. The conjugate of x is square root of x plus 2 minus 1. The conjugate is square root of x plus 2 plus 1. So both side I can take the multiplication of this portion, right? So I can take the multiplication of this portion both side. So because of that one, nothing will change, right? So now what I need to do, right? So after I can take the multiplication of this one both side. Now if you look at this one and this one, if you look at this portion and this portion, did you notice something? What is that? So if you look at this both, maybe this is like a minus b into a plus b, right? So why I am creating a here, this is a, just think about x square root of x plus 2 as a minus 1 as a b, then this is a minus b, this is a plus b. So now if you have a minus b into a plus b, we can convert this into a squared minus b squared, the form of a squared minus b squared. So the same theory we can apply here, right? If you apply the same theory here, now what will happen? Limit x approaches minus 1. So for this one we can say a squared minus b squared. So it means square root of x plus 2 whole thing to the power of 2 minus 1 to the power of 2 over x plus 1. We have one expression x plus 1 into square root of x plus 2 plus 1. So now we can write limit x approaches minus 1. So here square root and square we can remove. Square root and square we can remove, right? Let's say square root of 4 whole thing to the power of 2 means that is equal to 4, right? It means square root of 4 into square root of 4. That is the meaning of this one, right? Square root of 4 to the power 2 in the sense square root of 4 into square root of 4. So now we can say square root of 4 is equal to 2. Here square root of 4 into 2, 2 into 2, 4. Right? I can directly write this one, right? So now here we can remove square root and square. Then the remaining is x plus 2 minus 1 to the power 2, 1. 1 to the power 2, 1. So minus 1 over x plus 1 into square root of x plus 2 plus 1. Right? So now we can write limit x approaches minus 1. Here x plus 2 minus 1. So we can write x plus 1. 2 minus 1, x plus 1 over x plus 1 into square root of x plus 2 plus 1. Right, here we can cut down x plus 1 both sides. So now what will happen? Limit x approaches minus 1. 1 over square root of x plus 2 plus 1. So now here we can directly replace the values, right? So 1 over here for x we square root of, for x we can put minus 1 plus 2 plus 1. So now we can write 1 over 2 minus 1, 1. 1 to the power of square root is 1. 1 plus 1. So 1 over 2. So this is the answer, right? So if you have any square root in your equation, so you can find out the expression. That expression we need to find out the conjugate. So then both sides of the equation you can take the multiplication by the conjugate and you can simplify the equation. Finally, after you can simplify, you can directly apply the limits, right? This is how we can find out the answer with the conjugates, right? So now we will look at this question. This question, if I directly replace here, the question is limit x approaches 5, square root of x minus 1 minus 2 over x minus 5. So if I directly replace 5 here, so here what will happen? Square root of 5 minus 1 minus 2 over 5 minus 5. So now what will happen? 5 minus 1, 4. Square root of 4, 2. 2 minus 2 over 5 minus 5. So 0 divided by 0 we are getting as an answer, right? We cannot provide this as an answer. So the simple way what we can do, you think about this as an expression. For this expression we can apply the conjugate, right? So now what will happen? Limit x approaches 5, square root of x minus 1 minus 2, the conjugate of this one. What is the conjugate of this one? Square root of x minus 1 minus 2, the conjugate is square root of x minus 1 plus 2 over, so both sides we can, so the remaining part x minus 5 already there. So the x minus 1 square root of x minus 1 minus 2, the conjugate is square root of x minus 1 plus 2. So both sides of the equation I take the multiplication, right? Square root of x minus 1 plus 2. So now this is a minus b, a plus b in the form. So limit x approaches 5. So here we can say x minus 1, square root of x minus 1 whole thing to the power minus 2 to the power 2 over x minus 5 into square root of x minus 1 plus 2. So now what we can do, here we can remove square root and square. So x minus 1 minus 2 to the power 2 minus 4. So this is equal to x minus 5, right? Here also x minus 5 we have. Then square root of x minus 1 plus 2. So now we can cut down this one and this one. Now if I directly apply limit x approaches 5, 1 over square root of x minus 1 plus 2. So now what will happen? If I directly apply 1 over, if I put 5 for x, 5 minus 1, 4, square root of 4 plus 2. So 1 over square root of 4 means 2 plus 2. So 1 over 4, right? So the answer is 1 over 4, right? So this is the answer, right? So this is they are giving here, right? This is the answer they are giving, right? This is the second technique. So if you can't directly apply the limit rules and if you can't find out the answer, first thing we need to check whether is it possible to apply factorization. We can find out the answer. If we cannot apply the factorization, the second thing we can apply whether there are any square root. If there are any square root, then we can apply the conjugate techniques. Both sides of the equation you can take the multiplication of the conjugate and we can apply a square minus b square the form. Then we can remove the square root, then we can easily find out the answer, right? That is a second techniques, right? So the third techniques. So if you look at the third techniques, here also limit x approaches 1. So if I directly replace 1 for here, 1 over 1 plus 1 minus 1 over 2 over 1 minus 1. So now here also we are getting, here what we are getting, limit x approaches 1, 1 over 2, 1 over 1 plus 1 2 minus 1 over 2 over 1 minus 1 0. So half 1 minus 2 minus 1 minus 2 0 divided by 0. We cannot provide the answer directly. So if you have this type of questions, what we can do, right, rather than we are directly apply, so what we can do, we can simplify this equation. The first thing you need to simplify this equation, right? Limit x approaches 1, 1 over x plus 1 minus 1 over 2 over x minus 1. So now what we need to do, first thing we need to simplify this equation. How we can simplify this equation? Limit x approaches 1. So now let's say we can take what is the LCM for x plus 1 and 2. So we can take 2 into x plus 1 as a common, right? So if you take 2 into x plus 1 as a common, so now what will happen? So here we have one expression 1 over x plus 1 minus 1 over 2, right? So I can take LCM, x plus 1 and 2 is the LCM. So then what will happen? Here 2 minus, so if I take 2 into x plus 1 as a LCM, so if I divide it by x plus 1, the remaining is 2. 2 into 1, so 1 into 2, 2, right? So 1 into 2, 2 minus here, if I divide it by 2, the remaining portion is x plus 1 into 1, right? So now if I simplify this, limit x approaches 1, 1 into 2, 2, 2 minus x minus 1 over 2 into x plus 1. Sorry, 2 into the bottom part is x minus 1, right? So the bottom element is, okay, just think about here. So then there is another element divided by, so then this portion is there, right? So divided by x minus 1. right? So now we can write limit x approaches 1, so 2 minus x. So if I remove here, I can forget this, my here 1 I don't need to multiple, minus if I take the, if I expand the bracket by multiply by minus 1, minus x minus 1 over 2 into x plus 1, right? All together we can divide it by x minus 1, right? So now for the top element we can say limit x approaches 1, 2 minus 1, 1, 1 minus x over 2 into x plus 1, then we can divide it by x minus 1. So now if you look at something, you can observe something. What is that? If you observe something, if you look at this one and this one, so you can look at something, right? Limit x approaches 1. So if I take minus here, if I take minus as a common, x minus 1, right? So minus x minus into minus plus 1 over 2 into x plus 1, right? Then entirely this one divided by x minus 1, that is the meaning, divided by x minus 1. So if I take as a multiplication, if I take this one as a multiplication, limit x approaches 1 minus x minus 1 over 2 into x plus 1, this division if I take multiplication, 1 over x minus 1. So now both side I can divide it by x minus 1, x minus 1. So now my equation is limit x approaches 1 minus 1. Here minus is there, here 1 is there. Minus 1 over 2 into x plus 1. So now minus 1 over, if I directly apply now, 2 into, if I put 1 for x, 1 plus 1, 2. So minus 1 over 2 into 2, 4. Minus 1 over 4 is the answer for this question. Minus 1 over 4. This is how we can find out the limit values in the third techniques, right? If you have a complex equation, rather than directly apply, you can simplify the equation, try to remove some elements. After that we can apply the limit, right? So now let's say we will explain with the this example, right? Okay, I will explain the next example, how we can simplify this equation and find out the answers. Here also if I directly apply, right, 1 over minus 3 x, if I put minus 3 for x, minus 3 plus 2, minus 3 plus 2 plus 1 over minus 3 plus 3. So it means 1 over minus 3 plus 2 minus 1 plus 1 over 0, minus 3 plus 3 0. So plus into minus, minus, so minus 1 over minus 1 plus 1 over 0, 0 divided by 0, right? So it is undefined. So then what we can do, first thing we need to simplify this complex equation, right? So how we can simplify, right? Limit x approaches minus 3, right? If I take 1 over x plus 2 plus 1, here also 1 over 1 we can write, divided by, so it means this equation is divided by x plus 3, right? That is the meaning. So now here if it is a 1 in the sense, here also 1 over 1. So if I take LCM as a x plus 2 as a LCM, so if I take x plus 2 as a LCM, 1 plus x plus 2, then right here, wait, limit x approaches minus 3, 1 plus x plus 2 over x plus 2 divided by x plus 3, right? Now what will happen? Limit x approaches minus 3, x plus 1 plus 2, x plus 3 over x plus 2, then divided by x plus 3, it is equal to 1 over x plus 3. If any division we can take multiplication, but by swapping the element, swapping the nominator as a denominator and denominator as a nominator, right? So if you swap this one 1 over x plus 3. So now what will happen? Both sides we can remove x plus 3 and x plus 3. Now our equation, if I simplify, limit x approaches minus 3, 1 over x plus 2. So now if I directly replace the minus 3 here, 1 over minus 3 plus 2, so 1 over minus 1. So 1 over minus 1, in the sense minus 1 is the answer for this question, right? That is given by here. Right? This is how we can apply by using the third technique. So first thing, apply the factorization and remove the common factors and find the limit value. Second, if you have any square root values, just you can find out the conjugate. You can take the multiplication by the conjugate both sides of the equation, then you can find out the limit value. Second technique. Third techniques, if you have a complex equation, complex fractions as an equation, just you can simplify the complex fraction and then you can apply the limit theorem, right? That is a third techniques, right? Okay, that is a third techniques, right? The fourth technique is, right, sometime let's say you have a limit equation. If you look at this limit equation, right, you are getting infinity or something, infinity as a answer. Sometime if you directly apply the limit principles, limit laws, you are getting infinity as a limit, infinity as the answer for some limits, right? So we cannot get infinity most of the cases in the limits, right? So now just look at here. I will explain this example. This is the next type, right? Let's say now here what they are telling, limit x approaches 0, 1 over x plus 5 over x into x minus 5. So now if I directly apply limit x approaches 0, what will happen? 1 over 0, 1 over 0 plus 5 over 0 into 0 minus 5. 0 minus 5 in the sense minus 5. Right? Now what will happen? 1 over 0. 1 over 0 is equal to what? Infinity. 1 over 0 is equal to infinity plus 5 over 0. 5 over 0 into minus 5, 0. Right? So 5 over 0 also infinity plus 5 over 0 also infinity, right? So whatever the number, if you divide it by 0, right, that is equal to infinity, right? So 1 over 0 also infinity, 5 over 0, whatever the number divided by 0, the answer is infinity, right? So now if you directly apply, you are getting answer as infinity plus infinity, right? So better we can avoid giving this type of infinity as answers, right? So now tell me how we can apply some techniques and find out this type of infinity as answers, right? So now I will show you how we are getting answer for this type of questions, right? So rather than directly we are taking limit x approaches 0, 1 over x plus 5 over x into x minus 5. So this type of scenario, what we can do, first thing we can simplify the equation, then we can remove some common elements, right? So now if I simplify this, what will happen? What is the LCM? LCM is both we have x. So x into x minus 5 is the LCM. So now x into x minus 5 as a LCM, x into x minus 5 as a LCM. Now what will happen? I can, let's say both sides I need to divide it by x. So the remaining element is x minus 5 plus 5, right? Now this is the simplified version of the equation. Now plus 5 minus 5 I can cut down. So x over x into x minus 5. Now my equation is simplified. Limit x approaches 0, x over x into x minus 5. Now again I can cut down both sides x. Now my equation is limit x approaches 0, 1 over x minus 5. Now if I directly replace, what will happen? 1 over, if I put 0 for x, 0 minus 5. So now 1 over minus 5. So 1 over minus 5 in the sense minus 1 over 5 is the answer for this question, right? This is what they are getting, right? So this is how we can answer this type of question. So if you look at the next example, here limit x approaches 3. If x approaches 3, 1 over, if I put 3 for x, what will happen? 3 minus 3. minus 4 over x squared. 3 squared 9 minus 2 into 3 minus 6 minus 3. So now what will happen? 1 over 0, 1 over 0 or minus 4 over 9 minus 9, 6 minus 6 minus 3 minus 9, 9 minus 9, 0. So 1 over 0 is infinity, infinity minus 4 over 0 also infinity, infinity minus infinity or infinity plus infinity we can provide as a, we cannot provide answers. So how we can find out the answer for this type of questions, right? The first thing what you need to do, limit x approaches 3, 1 over x minus 3 minus 4 over x squared minus 2x minus 3. Now if you look at these, right, even if you take LCM you have a trouble, right? So before you apply LCM for this type of questions, what you need to do, limit x approaches 3, 1 over x minus 3. So if you look at this portion, first thing you can apply the factorization, right? So x squared minus 2x minus 3, if you apply the factorization, the factors are x minus 3 into x plus 1, right? So I can directly find out the answers. If you can't find out the factors, you can apply whatever the techniques and you can find out the factors. So this is the factors of x squared minus 2x minus 3. So x squared plus x minus 3x minus 3x plus x minus 2x minus 2x minus into plus minus 3. So rather than I am writing this portion, I can write minus 4 into x minus 3 into x plus 1. So why I am writing this, then only I can easily find out the LCMs, right? So now I can write limit x approaches 3. So what is the LCM for x minus 3 and x minus 3 into x minus 1? Here we have x plus 1, right? So now the LCM is x minus 3 into x plus 1. So if I take LCM as this one, so here the remaining portion is x plus 1 minus 4 in minus 4, right? That minus 4. Now if I simplify this, limit x approaches 3, x plus 1 minus 3, so that is equal to x minus 3, minus 4 plus 1 minus 3. So x minus 3 over x minus 3 into x plus 1. So then both sides we can cut down x minus 3. So my equation is now limit x approaches 3, 1 over x plus 1. So now if I directly apply this 1 over, for x if I put 3, 3 plus 1. So the answer is 1 over 4, right? So this is the answer they are giving in this question as a 1 over 4. This is how we can find out the limit values, right? So that's all about the limit calculations, right? First we will understand the theory behind limits, right? So limit means we can analyze the changes with that particular value. If x, let's say limit x approaches 3, in the sense we can analyze how the values are varying if the x is equal to 2.999 or 2.99, 2.9, how that with that 2.9 that function will varying. Similarly, if the value of x is equal to 3.0001, 001, 001, 01. So likewise, we will analyze how the values are varying. Depending on that, we can find out the x approaches the 3, what is the function take, right? Then we will look at some limit principles, right? We will look at 8 to 9 different types of limit rules or limit principle. Then finally, now we discuss some techniques to find out the limit value. The first technique, factorization. Second one, by using conjugate. Third one, simplify the equations and apply. The fourth one, if you're getting a infinity plus infinity, infinity minus infinity, this type of things. Here also we can simplify the formula. Then we can remove some common element. Then we can directly apply the limit principle. Right? That's all about the limits. Now we will move for the differentiation. Right? With the next session, we will move for the differentiation. Also, that's all about the theory. Now I will share some exercise questions. First of all, you can do the exercise with yourself. If you can't find out the answers, maybe you can discuss with your friends, right? First you can do all the exercises with yourself, and you can compare the answers with your friends. If you have any differences, try to discuss with your friend and try to find out the answers. Even if you can't find out the answers, you can contact me, right? You can contact me, or we will discuss those things in the physical class, right? So now we will move for the differentiation, right? So now we are discussed the basics of limits. Now we are moving for the differentiation. The last portion is integration, right? Altogether we can say calculus, right? Okay, now I will share the differentiation slides, right? Give me 1 minute.